we get experimental science. We're curious, non-judgmental.
We're just reviewing where we were for the fossil hunting before we start imaging some of the fossils that were actually raffled off over the weekend. These belemnite fossils, so these are that squid pin equivalent. They are extinct now, but still I thought it'd be really cool to be able to check out and see some of the detailing on there. So right here is the animal, and then this is the tip portion, that's what's been preserved. The pin, there's that pin portion just like you're seeing in the image above. And so we'll take a look at some of these underneath the microscope today. We're also going to be looking at some shark teeth. You'll be able to see here the different types, and we can scroll down and actually try to identify what we're having. So the Cryptoma, the goblin shark is the one that we found in the past. I think that's the one that we have a pretty big tooth sample of. Here's another example of like the lateral tooth versus the anterior tooth, so we can get that resolution of where the teeth are and what exactly they look like. These are late Cretaceous era shark teeth. We're just about to put some shark teeth under the microscope. We don't know what they are yet. Found them at Big Brook, which is the fossil place that, you know, the area we were fossil hunting this past weekend. Let's take a look at some of the older teeth just to kick it off before we get on some of the new ones. Probably this is my favorite one that we found so far. It is big enough of a sample that we actually can't get it all in view, which is always a nice problem to have. But you can see this, it just continues on, and then there's the base of it here. This is our largest sample to date, and it is a beauty. It's a bit of a goblin shark tooth. You can see it's a very, very similar shape too. That is the anterior goblin shark tooth that we found. That again is one of the older ones. And then let me show y'all another example of a different flavor shark tooth. This one. This is another one. It's a different species of shark. Y'all can see immediately, I think, that it's smaller, yes, but the biggest thing is there's a lot of structural differences, and you can see that it's serrated, so there's these little nooks and divots and crannies in there. We think it's the crow shark for this one. So this one is the difference here. So you can see right on this one, it has those serrations, which Andrew was mentioning look pretty cool. Then, this is our view here. I didn't do anything with them. This is just how they look like when we pulled it out of the water, which is kind of wild to me. There's that little doublet there too. So the reason I picked this one is with suspicion is this is also a goblin shark tooth. So if you look right here, chat, do you see how there is these two little extra divots here and here on either edge of the tooth? So if we take a look at our sample, there's one of those divots right there, and it looks to me like this region could have just broken off. So we thought that this was a lateral goblin shark tooth. And yeah, like y'all said, it's beautiful in terms of like how clean it is. And yeah, Supreme Doom, we did no polishing. Like the river and creek was doing the polishing for us. So this one's again a potential crow shark that we were looking at. You can see all the serrations along the edges here. If we switch over to our key here, again, it has those same little ridges along on this extinct crow shark. Again, same kind of serration patterns to it. We have part of it, busted off, so it's not as nice of a specimen as the one we were just looking at. But still, it's really cool that you're finding late Cretaceous fossils and just by sieving around in a creek. Like, it's really, really remarkable stuff. And then let's take a look at one last goblin shark. Here we go, check that out, y'all. Another one of those goblin shark teeth. And it's just so, like, the scale that we're looking at here, just to give y'all a sense of how big this is, 2 centimeters in length. So again, it looks massive next to my head. It's 7 times magnified right now with the camera that we've got underneath the microscope. So that is what we think that the teeth are from. This kind of fish. Deep sea animal currently, but again, we don't know the depths at which the New Jersey area was underwater at that time, right? 70 plus million years ago. So these animals were swimming around in that area. The crow shark has already gone extinct. There are still modern ancestors of the goblin shark around. There has probably been evolution across that 70 million years from the ancestral state of the goblin shark to what they look like now. But everything we know of them, the ancestral state is inferred from what we have now, right? So if you look at them now, you see their behaviors, we assume that they're going to be existing in the same way. They're going to be doing similar behaviors, the goblin shark. And again, y'all, it's kind of crazy to me that we have teeth from this animal 70 million years old. So y'all, I'm already having a suspicion of what this shark tooth might be. I think it's another one of our goblin sharks. Just again, looking from the structure and the angles, I'm thinking it's probably more along the lines of that anterior tooth. So I guess there's 2 possibilities, y'all. We could be having the lingual tooth, although the lingual ones usually have like this region here much larger. And if I take a look, show y'all, these are what the teeth look like. And so here's examples of the lateral and anterior and lateral teeth. Now the region I was looking at right here, these, like the classic anterior teeth, much more have this like extra nook, but then here, we look at this anterior tooth, it looks much more like the one that we have underneath the microscope now. So with a little bit of a smaller edges, and this could have been just worn off, right? Like just the erosion that's happening within the water. It's like being swept down. So that's my suspicion here, is that we've got another anterior goblin shark tooth. Flip it around. You can see here there's a large chunk of it missing from this side, this under part of the tooth. Like this is like a lot of it's just almost shaven away. And as we're looking closely, so the region I'm just honing in on is this rim here. Sometimes we're able to see if there's any serrations there by just like turning up the gain, which is this brightness, and seeing if there's any see-through bits that looks like, you know, the edge of a bread knife. And this part actually still has some dirt on here, but it would be extremely difficult given the size of the tooth to really clean that off with like something really strong without damaging it. But it also means that we're having difficulty seeing if there's any pattern there. If there were these serrations or these like, you know, the micro nicks that you've got on a bread knife, this area is actually going to start to look see-through in like little triangular shapes there. Because like of the dirt here, presumably it's not going to be there because we suspect it's a goblin shark tooth. But if it were to be there, we would have blocked it off simply because it's just missing here. Like we aren't able to see it. It's not like this one here where the ridges are like really well preserved. It's more like it's been shaved down with time and just like being scraped along in the sand. And so it's flat, but if you look, there's slight differences in color and how well the light passes through. And that's primarily because it passes through differently of different areas of thickness. So even though everything's been shaved down, the regions between those little serrations are thinner, and so the light passes through cleaner. Here again is the edge. I'm not seeing the edge as I was telling Sparky of like if there are serrations or not, but there's still a whole bunch of detail that we're able to see. So travel the world, you have a goblin shark tooth. Belemite are the equivalent of squid pins. They are from an extinct species. They're no longer around today. Here is the tip of the Belemite fossil. There we go. And actually, Sparky, this part, this phragma cone, if you take the Belemite, this one not so much, I'll show you all the end of it. This end doesn't have the opening, but some, you can actually look inside and see a little bit of the triangle. And so you can make out this region in the Belemite. And we actually have a cross section where you can see this phragma cone inside of the guard. And so it's this component here. Now this, the rest of it here, Sparky, of the squid, this one, that part doesn't fossilize well. There's a couple of examples of there being like these squid tentacles that were fossilized, but it's more like the imprint is fossilized and not the actual tissue because it's soft tissue. So you don't really get that, but the pin, this is the upper part here, that's what's getting fossilized. So for example, to like jellyfish, Sparky, you won't get fossil jellyfish, but you'll get fossil imprints left behind by the jellyfish, which is really cool, find anything like that. So same thing for our little squid here. There's an imprint of the tentacles, and that's what we know, like that's why we know what it looked like. And there's like a pin associated with it. You know, here is the actual specimen for Fishman. Let me show y'all. Note in the cross section, internal cone shape isn't there yet. So that proto-cone that's inside of the Belemite is further down in where the specimen would be. So we have to move further down along, and then we would start finding that additional cone. But the tips are the parts that are like, you know, people would tend to go like really excited about because like you get to see, you know, that's like the end of the animal. And this one, it's nice because it hasn't yet been worn down so much. Like it's still like not sharp, but you can still see the cone like triangular tip of it. The other interesting part of this guy, this tends to happen a lot, it seems like with the Belemite samples in that area, but there is this crack that's running through here. So a lot of the Belemite pieces are actually snapped in two, so that it looks like there's a lot of cracks that run down the midline, and then the samples break in half. And what's really cool is like that this one is like it was maintained. Like it's, yes, you can see the crack forming, but like everything is still there and visible. Sparky, this is that imprint. So here is the Belemite fossil that we normally find. right up here, and then the rest of that is the imprint. That's not that's not anything like physical, it's part of the stone. So Fishman has that really bright orange one, but then Jaded wanted this one. Y'all can see it's a different color. If I hold it up to the light, it does kind of sheen through with that orange color, same way Fishman's had, but it's not polished. So there's still like some debris that's been growing on it and like collecting on it in terms of dirt. I will say, if you look right head on, there's a small triangle on the very tip, that region of the belemnite, and that's that beginning of that inner cone core. So we'll take a look at both angles here. It almost looks like barnacles or something that have grown on it. See, that's the nice part. If we zoom in with the microscope, we see it's not barnacles, but there's additional type of stones here that are embedded in the crust of it. The difficulty, Fishman, I took off my glasses because it makes me frustrated that I cannot give you a good answer. In terms of predicted structures, yes, there is relation between your Nautilus and your Belemnite, but in terms of like phylogenetic relatedness, which is usually where I come in, what is the genetic relatedness of these different animals, that's where we have nothing to go off of. And then you have to compare your modern day squid to your modern day like Nautilus relatives and see like what the relationship is on that front. There is expected relatedness though between them. I just can't tell you what level of relatedness there is between this extinct species and the Nautilus. So what you will see actually is within, when we cut this in half, this region, so this setae and the Ceophene, so this usually Fishman is missing. This region right here that's filling in that internal cone shape. What it looks like to me is this sample from Jaded has this bit to it here. The very tip of that cross section is what it seems like to me. So right here, this region is indented. So this is the cut side of the belemnite, going the cut right along there where it was broken. And Jaded, this region here doesn't just look like it was randomly damaged. It's on the cross section. You can start to see there's an indent here, and that's where the beginning of the internal cone was, right on there. That's the beginnings of that organ right there. Like this will come out to have another cone. That inner bit is where you'll have like the organs and whatnot. But so we don't have that in this one. This is just like the fossilized outside of there. So this is a cross section, Sparky. You can see here that's cut right down the middle. This bit here would have been like, this is where the organs would have been, and other stone has settled in, so it's a trace fossil, meaning it's kind of preserving what was inside and like leaving the remnants there. We do not have like the actual soft tissue fossilized, but what's neat is this has filled up, right, that cross-section inner region. So we can see here what the inside looked like. And so what Jaded had, the cut site was right here. And so it just, that little bit of fossilized stone wasn't there. So if we compare, right, here's the piece that Jaded had. Cut along here, a little bit of an indent. Here would be that same indent, just there's no fossilization within that. And yeah, you can further see here, we move down, this again, which is split like this, and there's this trace fossil. So the trace fossil, Sparky, is just like a remnant outline, and it fills in via minerals and dirt. So the inner bits aren't going to be, organs are not going to be fossilized. We have some specimens where it looks like there's these little holes running through, and these are more than just random holes in a rock. They look like what are like some kind of worms lived within those holes and bored within. So what ended up happening was they died within there, and then it just preserved around them, and so it kept a trace fossil like that. So you're tracing the leftover material of the animal. And here, the trace is filling in the mineral inside of the squid pin equivalent, the belemnite, yielding this like unique internal structure. We have one more specimen to look at, and we got some 70 million year old fossil shark teeth and identifying what they could be. And I think this is a pretty easy one relative to our key. This looks like it's one of those crow shark teeth. This is tiny tooth. This is one that we collected on Saturday. This is about 1/2 centimeter in height. Super tiny, but this is a crow shark, and this is an example of the extinct crow shark. And if we look at it underneath the scope, very similar shape. You can see the serrations here. Those are those jagged nooks and crannies and divots. And we're just going to take a look at the other side of the tooth. Here, y'all, is the underside of that crow's tooth. See the serrations behind me? Notice that it's pretty nice.